Hello everyone, welcome back to the channel. Today we are diving with the another real-time use case, that is your loan default loan prediction. In this data, using this data set, we will predict whether the customer is defaulter or not. Or in other terms, whether the customer will repay the loan or not. The challenge today you are going to face in this data set is the number of columns. So this data set contains a lot of columns. So we are going to solve the challenge in this data using this data set is how to do the feature selection. I am going to introduce you today the three methods again. Number one, your EDA. Number two, feature selection. Number three, data visualization. In our previous predict customers churns data set, I have also divided it into three parts. The first part was about your data analysis, in which you face the challenge about the imbalance of the data set actually. And I also explained how you can handle the missing value, how you can handle the outliers. So I am picking the real-time use cases which contains the most common problems and the challenges, and I am trying to provide you the solutions so you can become strong in building the model. So let me give you the first blueprint. Let me open my whiteboard. So I will give you the just overview first, then we will actually jump onto the practical notebook, like what you are going to learn today. So today we are going to use number one, the data set, that is your default loan prediction. This is we are going to use. The challenge in this data set is lot of features, right? So we need to solve this. Okay, it contains lot of features. Number two, as a bonus point, it is also imbalanced data. If you are new to my channel and you are at a beginner level, then these two problems you are going to face most oftenly during real time. And this is the most common problem. If you are watching this video, watch this video till the end. Okay. And in this, I will tell you, we have contained above 2 lakh records. And we have a 17 columns in this. So what is the feature selection actually basically? Feature selection means you are going to choose the features which is like most important for your model prediction. So today this is your challenge, okay? And in first step, you are going to learn about the EDA. In the second step, you are going to learn about the feature selection. In the third, you are going to learn about the data visualization. And we are going to use today again pandas, numpy, matplotlib, seaborn, random forest, chi-square, and SelectKBest. Sorry. Okay, so these are the mandatory libraries we are going to use today. Okay, so in the EDA, what you are going to learn in the first step, we will load the data set and then check missing value, duplicates, right? And imbalance of the data too. Okay, and then we will handle them all. Okay, I am going to use for this one SMOTE method again. Or I would say the advanced method of SMOTE, that is SMOTE ANSI. SMOTE ANSI method is very popular to handle the numerical categorical your values. So it can create the synthetic data according to the data type of your feature. So this is very like the good method, more good more than your SMOTE one. Okay. And after that, in the second step, the feature selection, before doing the data visualization, we should do the feature selection actually, because it's very hard. If you have a lot of features, your data is in a high dimensional, it's very tough to visualize it actually. So we will do the feature selection. In this, the first method we will use chi-square. This will help to select categorical feature actually. But our data set contain the numerical too. This is basically popular for actually for the feature selection categorical, but it doesn't mean you cannot use the numerical. But the thing is, you need to convert your numerical data into discrete data type. So your chi-square can calculate the scores. So what does it mean? Let's say you have a age column. You have a age 18, 20, 30, right? So discrete will convert it into like this, 15 to 20, 20 to 30, something like this. Then you can use with the chi-square. Okay. So I am using both variables on this. So I can show you. Okay. And then the second one is random forest. We are going to use this method for feature selection. It works based on the, actually, this is based on the ensemble model. It creates the multiple different models, and on the majority of the voting, it will then aggregate those model and give the final output. In detail, I will explain it tomorrow when we will do the model building. Okay. Today we are going to use it for feature selection, and here it works for numerical and categorical both. Okay. So it is also we use for the feature selection when we know there will be the non-linear relationship. Okay. And the third is we are going to use select K best. This works for both type of variable. For both type of features, like a numerical and categorical both. Okay. And it is also a work based on chi-square statistical method, because we need to calculate the score first. This is also statistical method, and this is not statistical method. This is a model you use to predict, to choose the best your features which is going to contribute in your model prediction. So this is the most important feature. Look at it carefully. This feature selection also come under the feature engineering. Okay, this is a part of your feature engineering. If I told you here in short, I have already built the video on the feature engineering, but I'm just giving you the recap. Just ignore my spelling mistake. So feature engineering contains your handling missing value. This is also a part of feature engineering. It is a feature selection, choosing best model. Okay, because we do the hyper tuning and many things. You can watch my playlist for this one too. Okay, so this is you are going to learn today. Okay, this is I have done in my previous use case. So in short, I will make the videos on the like the real time use cases by picking up the specific and most common problems students face when they try to build the machine learning model. Okay, so now if you are new to my channel, don't forget to subscribe my channel, hit the subscribe button and notification button so you don't miss any video. Because in part 2, I will come up with the your model building, okay, and the evaluation too. I remember I have also promised that I will apply the random forest on customer prediction, churn customer prediction too. Because we wanted to apply the random forest classifier on that. So that's why I'm making this video first. because you will have the clear idea about the random forest classifier, how it works. And then I will make the part 4 for my first series. Okay, and don't forget to like my video if you like it. Okay, so let me open the my notebook. Here we go. Okay, again I am repeating my tips here. Always talk to the stakeholder and domain expertise when you have the raw data in your hand. This is very important. Students did this mistake at a beginner level. They just read the goal. They just thought, I know each and everything about the data, which is wrong. If you don't understand about the features, its data type, what is the functionality of the feature in this domain, in this particular data set, then you won't be able to handle the missing value correctly. You won't be able to do the feature selection correctly. Okay, so this affect the model health definitely. If you're thinking from where we will find the now stakeholder or domain expertise, then Google is there. Why don't you just read about the specific domain using from which you are picking up the data set? Like we are picking up the data set from the bank, right? Loan defaulter. If I don't know any stakeholder or domain expertise, I will find on the Google. I will look at the data dictionary clearly, and I have downloaded this data dictionary from the Kaggle. If you want to download the dataset, I will share the link in the description box too, and I will share the data link here in the notebook too. So you can download it from here, and there is a no restriction on you. You need to use this dataset for the feature selection. If you have already one dataset in your hand and it contains a lot of features, then you can use this one. I mean to say you can use this process. So the most important thing is to understand the process, how we choose how we do the feature selection. Code is the second priority. You should know how to write the code, but just to keep in your mind, first understand the process, first understand how you are going to implement, and then write a code. Whenever someone is teaching you in a normal, right, when you are learning, you just start focusing on actually code. You will start focusing on what the instructor has imported, why they have declared that this instance, this is the method. They don't focus on actually process, why we are using this method, how we are using this method, why I can't use the other method. They don't think out of box actually. They just keep focusing on looking at the code. Don't do that. Today, just look the code too, but give the priority to understand the process, what I'm saying you. Okay. So now let's start. We have the loan defaulter dataset. It contains the 17 columns and many records. And it is a classification problem. Your goal is to predict whether the customer is a defaulter or not on the loan. Okay. So here in the part 1, you are going to learn about the exploration, visualization, and feature selection. Here we are loading the dataset. Again, you need to make the copy. In a one line, I will explain because I have already explained it in a detail in my previous videos. If you missed that and you're new to my channel, you can watch that. Okay. So this is important because we don't want to make any changes in the original data set. Okay. And then we will remove the loan ID. Sometimes students ask me, why Nija we always remove the ID? The reason is it contains the unique values. If there is a too much uniqueness in your any feature exists in your data set, this is a one example loan ID. It can be customer ID, it can be ID, or it can be category too. Okay. So in that case, your model is not going to learn anything from this because when your model will try to predict, build the relationship with this feature to the target one, it will again change. So your model will not learn anything from it. If I give you the layman example here, if I am going to give you the questions, 10 questions, right, on a first day, and the second day I am giving you the again 10 questions, but I just change the domain from the first 10 questions. So you will not get a chance to practice it again, right? On the first day, you have just understand the basics, right? You just look at it. This is this, like for example, on the first day, I have given you the question answer on supervised machine learning. And the next day, I have given you the question on reinforcement, which is very far away. It's a unique topic for you again, right? On third day, I have given you the unsupervised. On the fourth day, I have given you something else, right? So you won't be able to build up the relationship, right? You want relationship means you won't be able to build up the connect it with the like your memory, right? Because you are learning everyday new thing. We need some stability, right? So if you first like focus on the Python properly instead of jumping onto the machine learning directly, this is you can learn from here as well. Okay, so that's why we delete it. Okay, and EDF info, here we will use this method to check the how many records you have, how many columns you have. We have 17 columns. That's why we are doing the feature selection, which is the biggest challenge today for our real time use case. Okay, and then describe method. This is very popular to check the statistics of your data set, of your numerical feature. Like here is a mean and this is a maximum value. So you can see here, it is showing you the like the data. If your mean, your maximum value is very far away from the mean, this means there are some outlier exist, but it doesn't seems to be. So that is looks fine. Okay. Now we will move ahead. Here is your, we are just checking the duplicated data and missing value. Here there is a no missing value. I was just checking the index value of the missing one here. So you don't need to do that. This is, I was doing some experiments. Okay, this is if you want to learn, this is just if you want to look at the, if there is any missing value at what specific index value. Sometimes you have the missing value in the target column. Okay, if there is a missing value in the target column, right, if it is a 1 or 2, the wise decision is drop it, because we don't want to handle the target missing value. Okay, and if you are trying to match the values with the like my copy and it is not matching, you don't need to worry. Okay, maybe you are downloading the data from different resources, there are some mismatch of the values records. Okay, so you don't need to worry about it. Just to focus on the process what I'm doing right now. Okay, we are doing EDA actually right now. And then we are just, because it's a classification, you have a lot of your categorical feature in this. Look at this, right? You have a education, employment type, marital status, has mortgage, has dependents, right? So what we want to do now, we want to see the uniqueness of each category. If we, again I am saying repeating, if you have the education, like it comes some customers are bachelor, high school, masters, PhD, and it is showing 20-25%. So this is enough, right? But if it is showing only 1%, 2%, 3%, this means there is a uniqueness. So it is not going to contribute in model prediction. Your model will not be able to learn anything from this. So this is very important to check the uniqueness of the category when you are working with the categorical data, especially in the classification. Okay. So it is just a result of each. You can go through it when you download the notebook. And maybe you are thinking if there is a like a too much uniqueness, right? The values is keep on changing, right? Like for the first record, it is showing high school, then it is showing a PhD, then again it is showing high school, again this one, right? So like maybe other new value too, master's degree, bachelor degree, something like that, right? So this is called high cardinality. This is a separate topic. This is also a part of feature engineering. Okay, but we are not going to discuss that today. I will pick up some another data set which is showing you the unique category and how you can handle that. Okay, over today, most biggest challenge is feature selection and imbalanced data. Okay, so this is we are going to gonna focus on that. And then we are just checking the imbalance of the data set, because we can just pick up over target value default and just look at this. 0 belong to non-defaulter who already repay the loan. 1 belong to who are defaulter who did not pay the loan, right? So, but you can see the imbalance of the data. It is very far away, right? We have a very less number of the records. Now, if I will try to build the model using this one, which I have showed in my previous series, intentionally because I wanted to show you the difference. So your model might become biased actually here. Okay. Tomorrow, maybe in your new data set, you are giving the, let's say, 200 value, your defaulter, and 10 values, 100 value or 150 values for the non-defaulter. But your model will say, might be predict the 150 values as a, out of 150, your non-defaulter value, some values out of it, let's say 50 records or 100 records as a defaulter. Okay, because your model is biased. It won't be able to build the strong relationship in case of known defaulter. Your model did not get a chance actually to learn about it more because we have a very less number of records. So this is called imbalance. This is not good for your health in for your sorry not for your model's health in any case. Okay, so this is very important to handle it before you are building the model. Okay, so we will handle it first because before the feature selection even too, because when I want to apply the feature selection method I have showed you on the whiteboard, it won't be able to choose a feature actually, especially in case of random forest, because random forest is looking at the record, divided it into multiple models, and then voting the majority of the models, and then aggregate and then give the final output. And in that case your random forest might become biased. So it is important to do that. Feature selection is also should done after the balancing. Okay. Now we will separate the x and y because we want to apply now SMOTE method. Okay. Here we are doing it right now for the overplotting as well, just to show you the same thing on the graph. So 88.39% you have the records, the customers who are not defaulted, and defaulter are 11%. So it should seems to be equal, or little bit difference will work, but this much big huge difference is imbalancing. Now we will balance the imbalanced data using SMOTE and C. In my previous video, I have used the SMOTE method. This is advanced version of your SMOTE. So it is going to handle your numerical categorical data. It will generate the synthetic data in a proper way. Okay, so this is also best. That was also best. This is also the more advanced. You can try both. Okay, there is a no problem, because if you think that after applying this your balancing data model building is performing good, then you can go with this one. If you think SMOTE will work more good, then you can try with that one. There is only little difference by looking at by generating the your synthetic data. Okay, now here it will here it is going to separately actually focusing on the your numerical and categorical. In SMOTE, it doesn't care about the your type of the feature. Okay, it just generate by looking at the values, right, and generate the synthetic data. Okay, and now we are just doing separating it, and then we will convert over categorical data into numerical. Okay, because before applying the SMOTE we need to do that. And then we are just picking up here the x dot columns get this one in categorical, and SMOTE and see it will automatically help pick up your numerical data, and then we are just balanced it. Now look at the difference. 0 belong to this much value. This is equal now, right? So this is the a very good method to generate the synthetic data when there is an imbalance. There is a random oversampling, random undersampling methods too, right? This is your choice if you want to use it. I didn't use those methods because number one, my data set is big. Okay, random oversampling works good when your data set is simple and small. Okay, because it will sometime happens definitely with the random oversampling, the overfitting. Undersampling, this is also good for the like in some cases for the data sets. Okay, so I like the SMOTE one, so I'm using this one. Okay, so now what we will do here, we are doing the just this comparison. Here I would like to clear you one thing more. Maybe you are thinking, Nirja, why are you using the label encoder to convert your categorical data into numerical? Why you didn't use the here one hot encoder or other methods? First question may be coming in your mind. Second question, maybe you are thinking why you did not split the data. Okay, because we don't need to split the data here. We are not handling the missing value actually. Okay, we are just normally converting our data into the numerical. That's it. There is a no data leakage. Okay, that's why we are doing it without split. Number two, here I am using the here the label encoder instead of one hot encoder. I will give you the very good example. Look at this. So this is your education column. Okay, so some customers are high school, some have done the PhD, right? Some is from the bachelor. When you will apply the one hot encoder on this, look at this, what will happen. So I will keep it here. So it will, this is your original column, education, right? And this is your, it will, when you apply the one hot encoder, I will write it here, one hot encoder, okay? It will create three more columns now. This is PhD and this is your bachelor, okay? H, PhD and your bachelor, okay? So when high school is true, it will say 1, other will become 0 in case of one hot encoder, okay? So this is not L, this is 1, okay? And now this is PhD, it will become 0 and it is 1, okay? And this is your 0, 0 and 1, okay? In last, it will again create a one column. Default. If no category is there, then this is the default one. All will be 0. Okay. So now you can see it creates a 3 or 4 columns more. Your data is becoming more dense. Okay. But if you are applying the label encoder, let me scroll it. Okay, it is not scrolling. So I will draw it here. When you apply the here label encoder, which we are doing using in our current method, okay? So this is going to not create any like the extra column. This is your education and this is going to be your label encoder, okay? Here it is high school and this is PhD and this is bachelor. It will assign the high school 0, PhD to 1 and bachelor to 2. So they you can see the difference now in the between the your one hot encoder and your label encoder. So your data is not too dense, right? So this is best for your during the feature selection actually. If you are going to create this much column, you are going to apply get dummies or one hot encoder. What will happen in that scenario? When we will apply the feature selection methods, your it is hard for your like the feature selection method to choose the best feature because it will see so many features, columns, right? So this is not the good idea. That's why you should go with this one. Okay. So this is very important. Note it down. Okay. Why we are using it. Okay. So now we will clear all drawing and I will come on this side and we will continue. I hope it makes sense. If you still have a question, drop a comment. I'm happy to answer. And now we will move ahead. Now we will do the feature importance and selection. First of all, we are using the first method, heat map. This is your best friend, right? By default, you use this method. I always recommend my students at a beginner level, why are you not using the correlation? Sometimes they forgot it totally. They're just focusing on handling the missing value, duplicates, outliers, that's it. And when they have a lot of features, they just trying to fit all the features onto the model and their model will fail. And then they stuck at that point. So now, did you like focus on that thing as well? I have keep this thing in my mind. I need to use a label encoder instead of one hot encoder before applying the feature selection. This is the thing you need to keep in your mind too. This is not only about the one point I'm mentioning here. There are several points. So you should know in future what methods you are going to use. Is it going to affect my previous methods too or not? Is it depend on the previous methods or two or not? This is called process. This is called logic. Okay. So you should keep in your mind. And then we have a here heat map. Now look at this. This is your all features, right? And this is your target feature. All relationships seems to be very less, right? This is a negative relationship. The darker your mauve shade, right? Relation should be either negatively correlated or positively correlated and no relation. No relation, we are not interested in those features because it is not going to help your model to predict, right? We are interested in either the strong negative relation or positive correlation. Okay. Now look at this. There is a age. This is 30% connected with your this one. So this can be your most important feature, right? And look at the income and your monthly employed negatively correlated. And if you look at the here interest rate to 22%, very good, right? So you can choose the features from here too. Okay. Manually you can drop the other features. You can keep up the features, which is where seems to be important and showing some the relationship with the either negative or positive with your this one. This is the first method, most easiest, most basic method. Okay. The second is univariate selection chi-square test. Why we call it univariate? Because this work for the categorical actually only. Okay, but if you want to apply it on the numerical too, then you need to convert your numerical data into discrete, as I have showed you on the whiteboard in the blueprint in the start of the video, right? So here we are just importing the your KB in discretizer. This is bin continuous data into intervals. This is I have used to convert your numerical, like we have a age, right? We have other features too, so it will convert it into bins. So your chi-square will understand it and it will try to give us the score based on that. Okay. And then we will make a, now you are not going to use your normal data. We are only going to use the balanced data. And balanced data, we have X and Y. Y is your target, X is your all independent features. Okay. We are not going to use any more the raw data, EDA1. Okay. And then categorical feature, numerical feature, we will select from this. Okay. From your X. Okay. Converting your categorical feature again into the your labeling encoder, right? And then we are using to convert your numerical into bin using your K bin discretizer. I want to create 5 groups. Like if a age is between 10 to, let's say, age between 18 to 50, so it will create a 5 groups. Okay, for this. And convert encode it into the here cardinal one. Okay, your ordinal one, quantile. Ordinal means give the priority, ordinal data in the order. Okay, 0, 1, 2, 3. And then this is a numerical column. We will fit onto the this one, and then we, if there is any negative value, it will convert it into positive. That's it. There is no special purpose here. And this is apply the chi-square test. We are using the SelectKBest here too, because this is the method we are going to calculate the chi-square scores. Here we are creating the data frame, and then we are plotting it. Look at this. Higher the chi-score, good is your model. Okay, why? Because these features, you, if you are going to use these features with the highest score, this means this is going to help the model to predict the things correctly. Okay, so this is very good for your model health. The most important feature are age, interest rate, income, and then this. Okay, so this we can consider. This is not I will say that it is like a too much strong relationship with your target in the predictions than the age. Age is the most important. Okay, so it really matters. And I hope you understood this one, right? And then I have plotted the graph too. Here I am showing you based on the which features are important based on the numbers, the scores of the your chi-square test. But I have drawn the graph too for your more good understanding visually. Okay, so we are just to pick up the all scores here. Okay, whatever value you are getting from here, you can write it down. Okay, some values may be vary here. Okay, because I have just written the from this one, but here you look at this. We are just creating the data frame and then we are going here. Now look at the result. Age contains the it is the most important feature for your during model prediction, right? It has the highest chi score. If you are not able to understand here, then you can look at it here. Okay, so this is this one, and then this one, this one, this one. If you are not able to take an idea with the numbers, then visual is the best solution. That's why I'm drawing it. I try to make it descending. I don't know why it is not in the descending order. Okay, so you can plot it in a descending order too. Okay. The next method is tree-based method. This is very popular method, because it works for the non-linear relationship. Like if your independent feature is connected with your target feature in a non-linear way. Okay, like the non-linear means I will show you. Look at this. So this is your age, okay, and this is your default. Okay, if age is increasing this direction, right, we can say 10, 20, 30. Okay, if age is increasing, your default value is also increasing in the same direction, like this. Okay, so the trending line is like this way. So they both are interconnected with each other. But the non-linear, we call it a linear relationship, but the non-linear is something like this. Okay, your trend line will be either like this, or it can be like this too. Okay, or it can be like in other shape too. It depends. This is non-linear. This is not linear. Because this means that sometime age is contributing more in the prediction, like whether the customer is defaulter or not, but sometime it is not. Okay. And like in this too, if let's say if the age is right, at some point it is 10, it is saying the person is defaulter, right? If the age is 30, it is saying non-defaulter. So it is going up and down. Okay. So this is called non-linear relationship. So we will clear the drawing here. Okay. And now we will move ahead. So now random forest handles both type of variable. I have also like told you in the whiteboard too, right? It works for the categorical, numerical, both. You don't need to worry about it here. Okay. So now here it is a simple. We will import the random classifier. You don't need to import the pandas again and again. We have imported it above. And then random state is equals to 42. We will fit on to the balanced data here. And then predicting this one. So it is showing me the top 10 features. You can do the comparison what the chi-square was saying, what features the chi-square was giving you, best feature selection, what it is giving. So I have draw the graph for this one too. Look at this. It is according to your random forest, long term is the most important feature. But according to your chi-square, age was the most important. And according to this, long term was coming here. Right? Now you can see, right, difference, because every method that is a statistical method, right? It is going to work based on the statistical testing. It is going to work based on the model prediction. For me, this is more reliable. Okay, I wanted to show you the chi-square, actually the mostly feature selection method, so you can apply on your data set. Maybe you have the data set who only contain the categorical data, then chi-square is going to best. Okay, but you should apply more than one method always, and then compare and then apply the model, and then check which model is performing good and choose the best model. It is a long work, but you will learn very like the things at a deeper level. Okay, now look at this, then age, interest rate, income, monthly is employed, right? Something like that. So you can do the comparison, right? We can see the loan purpose too here. No, it did not choose it, right? But your random forest is choose here. Okay, so there is a difference. Okay, and then we have a next method. This is SelectKBest. Okay, this is also very popular. This work with the chi-square test, right? Because it is a statistical method. It is going to choose like a pick up the score value from the chi-square test, and then we can look at it. Look at this. So it is showing us has department, employment type, has cosigner, loan amount. It is also giving the priority to the loan amount, right? And it is not giving zero priority to the loan term actually. Okay, so it is showing you the different features, right? So for me, I am going to like use now in the model building a random forest, or maybe chi-square, or this one. Then I will tell you which model is working best. Right now, as a like by looking at all three results, uh, my recommendation is random forest. Okay, or either you can choose this one too. So you will see this tomorrow in the part 2. Okay, because today we are just choosing the feature selection. So this is over feature selection, you are done, right? Because it is giving you the top 10 features, right? And how many features if I want to choose till here? 1 2 3 4 5 6 7 8 9. You can choose 9 features. This is your choice. Okay, decision is your. These are the methods. Okay, now I will only come to know when I will see the model output, which feature selection method was the best. Okay, now we will start the visualization. This is normal. We are applying the comparison of your axis select target distribution. Now look at this equal. Previously it was 88% and 11%. Now it is equal, right? And then check the default based on education, like how the education feature is affecting your target. Okay, now look at this. So your orange or your this color, or we can say light red, right? It is on the this is a stack plot, and this is a zero. This is like the customers who are not a defaulter. This is defaulter. If you check the education level 1, maybe you are thinking what is the education level 1, because we have converted it into label encoder. It can be, might be higher education, right? High, like the high diploma, high school diploma, or it can be the PhD or something like that. Okay, so you can consider it. If you want to look at it, then you need to get the features name actually. How to get the features name? You need to check it out. I have also mentioned in the data analysis too, actually. Okay. So now here we can see if the education level is 1, I'm saying using just 1. So there are a more defaulter between the count is your 60K to 120K. Okay. And the non-default, like the non-defaulter is between your 0 to this one. So the highest range is about the defaulter. So the people are not able to repay the loan. Okay, and same for the others being too, based on the education level. Okay, and now we are looking at here we will just remove this, and we are just looking at here histogram of income versus default. Now this is the income from 20K to 140K. So one will become to defaulter. First look at the defaulter. So the customers who have the salary range like up to the 20K, they are not able to repay the loan because their salary range is low. But if they have the high salary range, then they are able to pay the loan, right? So this is showing you the here line to kernel density, right? Distribution of the data. It is very clear from your distribution how the income is contributing for to pay the loan or not pay the loan, and in the prediction of defaulter non-defaulter. Okay, and then this is a visualization about age versus default. So the age between or above 40, the mostly people are able to pay the loan, and the up to age 35, the people are not able to pay the loan. Okay, and then we are just between the interest rate. So this is also impacting. If higher the interest rate, more is the defaulter. This means if interest rate is very high, people are not able to pay the loan, like repay the loan, or you can say, right? So there are more defaulters in case interest rate is high. Above, you can say 13. Okay, up to 13, the people are able to repay the loan. Okay, now these all graphs are showing you very good way, and the most important thing is you don't need to do the data visualization for all features, right? Because we have already selected the most important features. Okay, and then I have plotted the top 10 features using the box plot graph. Look at this. This is only the your top 10 features. Okay, so here if you look at the loan term, it is not showing a median value, seems to be same, right, on the your box plot. So this is not, we can say, like a defaulter or non-defaulter. It is contributing or you're helping, the loan term is helping you to predict the more cases towards the non-defaulter. This seems to be equal. So this is a weak relation. Okay. And if you look at the age, yes, it is helping you to predict more defaulter, right? Because more is the age, like in this, say we can say the people are non-defaulters, so it is helping you. Okay, if you look at, for if we pick up of any other, this one, number of credit lines, this is also seems to be weak relation. Okay, not too much because it is not contributing. You can see here, like this is the, like median is at the center, and if this is telling you defaulter non-defaulter at equal level. Okay, so this is a way how you can interpret this graph. Okay, but the most important, most interesting thing I wanted to show you for the visualization, this is called visualization score. I don't know whether you have heard it or not, but this is a visualization score. It is going to plot your all graphs with the intuition of EDA. Whatever EDA, exploratory data analysis, we have done of the numerical feature, of the categorical feature of all the graphs, it will give you the percentage or the score of the like the each feature based on the visualization score, right? How much it is contributing in the model prediction towards your target. I will show you, it will make you more understand. Look at this. This is the score. This is the feature and this is the visual importance score. So what does it mean? This is the your age. So we have seen age, visually age is showing you the strong relationship between the with the target, right? It is helping the target. If age is increasing, people are not able to pay the loan, right? Or up to some extent people are paid the loan, right? This is something, it can be in opposite way too, right? But this is showing you the visual score importance too. This is very interesting thing. Okay, and you can calculate it. I will show you the code too. We will pick up our random your sorry SMOTE data set, balanced data set. We will declare one dictionary here, visual score, for feature in x dot select feature. So this is your all independent features, and then it will pick up the numerical column and then plot the histogram distribution of all numerical feature, how the all numerical feature is calculating it. Okay, and then it will calculate the correlation with the target variable for the all your numerical feature. Okay, and here it is just passing the feature here which we are selecting from here and then multiply by 10. This is for score, so it will tell you the scores, visual scores. This is the way how we are calculating. Okay, and then categorical feature, it will select the categorical feature and then value count, it do the value count and then length of the value count multiply by 5. Okay, so this is a random number, I am multiplying it. Okay, and then we will create the data from this one, and then it is showing you the graph too. Look at these graphs. First I have printed the score value too, so at the last, so you can look at it. Look at this age distribution, this is numerical, right? So it is showing you that if age is increasing, the people are about like the 70, they are able to like pay the loan up to some extent, right? And this is a count of these people, this age, right? And here you can see the more people, customers in the bank who take the loan between the age 20 to 40, right? Here the distribution of the data is very high. That's why age is contributing a lot in your model prediction. Okay, now look at this income. This is between 20K to 140K. So maximum people in your data set is between the in with the income 20 to 25K, right? So it seems to be stable. 6,500 customers are between the range of 40K to 140K. But most customer above up to 10,000 or above 10,000 customers are belong to this income range. Is this good or not? Right? Because it is telling you even the each like the distribution of each record in your data set. It is giving you the idea this much record you can have in your data set. Okay, And now if we look at the loan distribution amount, loan amount, how much loan the people are able to take. So maximum people who took the 250K loan, this is range is high. But between the range of your 0 to 50K, the people is 5,000 in the range. So maximum people who is taken the loan above 7,000, yeah, above 7,000 is this much the loan amount. This is also giving you, this is very good graph for your stakeholder too. If you wanted to show the bank stakeholder, these are the people, you have a high range of these people who are taking this much loan, right? And then look at the credit score. How many people have the good credit score? So the people who have the credit score 500, you have a this much people above 6,000, and who have the 800 credit score, they have the this much range between 4 to 5,000 people contains this much credit score. This is the most important your like the feature in the loan, right? Because whenever you are going to bank, they check your credit score. Based on that, you will get the loan, right? This is the first thing they do. So this is a graph for that. Okay. And then look at the monthly months employed distribution. So how many, since how long you are employed. So if you look at these, 120 months are, you have the people in the range of between 4,000 to 4,500, but maximum between the range 20 to 40 months, right? And then this is your number of credit lines. How many credit lines you have? The people with the two credit line are above 120K people in your data records. Okay. So this is a 4 credit line. How many people? 1 credit line. How many people in your data set? And this is, right? And then this is your interest rate. How many people are getting the higher rate of interest? You have the range between 5 to 6,000. These are the people who are getting a loan on the high rate of interest. So these are all graphs are very, very useful for you. You can draw this graph separate too. I have drawn it using the loop. You can draw it separate too. But this is the best graph for your like the dashboard too. If you are working with the default loan prediction. And look at this long term, sorry, loan term, for how many months you have taken the loan. So maximum, like if we look at this, common months is between 35 months. Okay. How many people you have? 60K. This seems to be almost equal. There is a little difference. But there are some people also too who took the like the loan for let's say 15 months, between 18 months too. Okay. And then this is the DTI ratio distribution. Okay. This is also the important feature. And then education, this is showing the education level 0, 1, 2, 3, whatever you have seen. Okay, so I'm not going to repeat it. This is employment type. This is again coming in the label encoder because we have already converted the data. We are using the actually SMOTE data here. So here this is showing you the employment type. Okay, part-time, full-time, freelancer, or whatever. Okay, so this is showing you the that one. Okay, and look at the marital status, whether they married or not, or common in-law relationship or something. Okay, so we, if you want, now you will see the check. If you want to check wherever we were looking at the uniqueness of the data, you can check it out. Marital status. Here we have this one. You have a single, divorce, marital, married. You have a 3 status, right? So you 0, 1, 2, 3. Okay. So that's why it is very important to do everything. Okay. And now we will come here. Has a mortgage distribution. Okay. Has a independent. So this is showing all graphs. Okay. And this is a score. Now higher the visual score, more is the like this means it is showing you, this means now age you have seen on the graph too, right? So which your graph is contribute visually, whose graph score is very high, that feature is going to contribute in your model prediction. That's why we are doing their visual scores. This is based on your EDA actually. This is not something we have calculated in advance. This is based on the visuals. Okay, and then we have this one. This is the last for your just more understanding. This is age has the most highest score. Maybe it will make more sense to you. Interest rate, this one, and go on this. This is the visual importance. Higher the score of the visual importance, more is the your important your feature is in during the model prediction. Okay, now this was the all about your EDA feature selection and your visualization. I have shown you the best visualization for this data set, and you have solved the, just the recap, you have solved the biggest challenge, feature selection. It doesn't mean you need to use this. You can use the another any like your real-time data set too, because I have told you the reasons too, like why we are using SelectKBest, why we are using the random forest, for what kind of the data it is best. It is best for categorical, numerical, both, and you can also use the chi-square if there is only categorical variable. And I have also told you the how to handle the another biggest challenge, imbalance of the data set using the SMOTE and C. And top of that, the best visualization and visual scores too. Okay, so this is the like the things I have shared with you today, from the basic level to the advanced level. Okay, if you have still have any question, I'm happy to answer. Okay, and I will see you in the next video. And if you are new to my channel, don't forget to subscribe my channel, click the icon button, like my video if you like it, and then we will see meet you we will see like meet again in the next part. Thank you so much.